So the question is, can wave energy converters be used to protect coasts from future hazards? And the answer to that is there's actually projects on the drawing board right now designed exactly to do that, where wave converters are being inserted into breakwaters as a way to basically reduce the stresses on the breakwater and generate power. So people are definitely thinking in that direction. People have thought about using wave converters as a way to protect offshore wind turbines from really strong storms. Mitsuhiro and I also had a thought about using tidal turbines to try to offset sea level rise in Puget Sound, but we're getting to the point of getting to geotechnical engineering there, and that's a long ways off. So there are ways that you can think about trying to really make this an integrated solution to that problem, though. So great question. So the question is, what fraction of the energy do converters take out of a tidal environment? And the answer to that depends on the converter technology and on its packing and spacing. So an individual converter has an efficiency. It can harness somewhere upwards of 50% of the kinetic flux that passes through its swept area. Now, when you think about an array of converters, and so you have multiple rows, and you say, what's the ultimate carrying capacity of a system? That really depends on the dynamics of the estuary. So if there's kind of a classic curve of basically reduction in tidal range versus power generation potential, and it's basically a curve that hits. You keep going, you keep dropping the tidal range, you keep generating more power, and eventually you get to a turning point where you put more turbines in the system, and you actually get less power out because you've slowed the flow down. And that tipping point